Hello everyone, I'm Rajib Saha, I'm from Indian School of Business. So I'll talk about a couple of courses that I teach that are focused on supervised learning and unsupervised learning methods. And I'll talk particularly about certain components, not the course curriculum as much. So I teach two courses. One is business analytics using data mining. That's an MBA elective. And in that course, I focus on supervised and unsupervised learning both. And we have a 15 months long analytics program, graduate level analytics programs, and I teach another course there, and that is purely focused on unsupervised learning. So this is what I'm going to talk about. I will talk about, as I said, I will not talk too much about the course curriculum, but I talk in briefs so that I set the context for the component that I'm going to talk about. Okay. The components that I'm going to talk about would be a framework for a course project, and another framework for evaluating a project, okay. And another component would be the kind of offline videos that I've created to facilitate learning. And then I will talk about certain data sets that we use and how it kind of fits our kind of structure of the program. So these are the two courses I was talking about. By the way, these are not semester long courses. These are very compact courses. In ISB we run in terms. So this is one course, and each course is like 10 sessions, and each session is 2 hours. So each course is like a 20 hours compact module. So the MBA elective that I was talking about is this one, where 60 to 70% of the course is focused on supervised learning methods, and another 30–40% is on unsupervised learning. Now in that supervised learning component, the part which is which consists of 60–70% of that, I spend a lot of time in terms of how explaining and predictions are different. I spend quite amount of time in terms of how you choose a particular metric to evaluate how good the model is doing. So I spend significant amount on that, and then in that one, when I set the context of model choices or metric choices, I teach them a bunch of methods, which are again essentially supervised learning methods. Under unsupervised learning, I talk about clustering, I talk about principal component analysis, I talk about association rules and all. So this is the MBA elective, and this is the course in the analytics program which is focused only on unsupervised learning methods. There I talk about, again, a bit detail on K-means and hierarchical clustering. As part of dimension reduction, I talk about PCA, how PCA works, how SPT works, applications of those. I talk about association rules to find extract relationships, or I teach tools how to those are meant for extracting sequential patterns and all. And I spent quite some time on network analytics. Florin was in the morning session. You saw an example on GEFI with the network visualization and all. So I get into those metrics, the centralities, or the how you get cluster communities and all. I get into that, but I do not do the visualization as much. So I do it using R only, and using R APIs, they extract those network characteristics. So that's the kind of approach I take. So these are the courses. Now, as I was mentioning that when it comes to teaching those courses, I put a lot of emphasis on explaining what is explaining and what is prediction, okay, and then different metrics. When I say how explaining is and how it is different from how explaining is or what is prediction or how it is different from explaining, I talk about how the choice of methods could be different. I talk about how your choice of predictors could be very different when it comes to prediction. So you may have all the variables in the data set, but then just because you have in the data set doesn't mean that you can use all of them to predict a certain Y variable. It depends on your deployment scenario. At the time of prediction, you have to see what all variables are available, and accordingly you choose that. So I give examples where they get to see, well, it's in the data set, but you can't really use it, even if it could be a good predictor for that particular variable. So I spend quite a bit of time on that. I talk about the importance of cross-validation why it is so much more important in prediction. And if you had lots of data, how can you make your cross-validation or the prediction much more robust, your prediction model much more robust. And I talk a lot about choosing evaluation metrics. Okay, the kind of evaluation metrics that you choose for, say, a model where, let's say, the US Army is building a model to predict whether a plane is an enemy plane or not. The metric that you choose for building that prediction model will be very much different from the metric that you'll use to see whether a search engine is giving you the right results or not. So I give several applications, several examples and applications, and in those contexts talk about those metrics. So this is about making the difference between prediction and explaining. And now, as I was mentioning, that we have a very compact class. It's a 10-session class. You can't really cover each and every methods of machine learning. So you actually pick a few of them. And the philosophy that I have here is that I don't say that, you know, I'm teaching you method 1, method 2, method 3, method 4. The focus is on understanding what a prediction model is, what a matrix is, and then I choose some of these models and I position them as if, like, okay, this is the candidate method with this potential. Okay, so these are some examples of the methods that I go over, and I position them as, you know, this is. So we start with, of course, linear regression, logistic regression, because that's what they borrow from the statistics class. So I start, I use those two methods more like a stitching between the statistics class and eventually getting into some of the prediction heuristic methods. And this is how I position. So what I have here is the methods, and I say, you know, there are methods that you can use for if your outcome variable is a numerical variable, your outcome variable is a categorical variable. And then I differentiate between, again, prediction and explaining. If it is a black box kind of model, then those models can be very good fit for prediction, but you can't really use them for explaining. Like regression, you can use it for explaining by looking at data, but if you are using some certain method like KNN, it's a black box method. You can't really explain anything. You give an input, you give certain variables, and you get an output. So as you see, the yellow boxes are kind of telling you what potential those methods have. So when I teach those methods, I actually sell it as a method which can do this, this, this. Okay, and in a moment you will see where they will need this information when it comes to doing the project and all. So this is about positioning the methods. Yeah. A little bit details on evaluation metrics. So first of all, I kind of spend a lot of time again so that they are able to kind of identify the type of a problem it is. Okay, it could be a profiling problem, okay, or explaining problem. It's just terminology issues. Explaining is for numerical Y, profiling is categorical Y. Or it could be a pure prediction or classification problem. You do not have to really explain anything. Or even within classifier, it could be a classifying kind of problem, this type or that type. Or it could be, well, I don't care about this type or that type, I care about, if this is the type I'm caring about, could you rank those records? Okay? So they should be able to identify this, and once they identify that, then they have to really come up with the right choice of metric, come up with the right metric, where the applications will tell you how predicting one class is more or less important than predicting another type of class. So asymmetry of class importance, or the asymmetry in misclassification cost, what kind of metric or metric they have to choose, or what they have to do to minimize the misclassification cost, and all I'll talk about. And of course, these are some of the metrics that I get into, which are aligned with this concept. So confusion metrics or F1 score, precision score, that I don't have to tell you more, but this is where it comes to choosing the metric which is aligned with a scenario given a goal. Okay, so this is about the context of the course component that I'm talking about. Now, what I'm going to discuss is the framework for the project that I give here. Okay, so there are 4 deliverables for the project. One is first project ideations. They are supposed to come up with the idea of the project. and then I ask them to get an intermediate project report, and then they present the project, and then the final project report. Okay. So here, this is what I do. This is basically reading. I'll quickly refer to, I'll not spend too much time. So I teach all that, but then I don't have enough gray hair, so sometimes to reinforce certain aspects, I have to quote CEOs. So that article is a very, very good collection of reinforcing what I just teach them. And they,
You will soon enough.
I'm still claiming that I don't have enough. And then it's the ideation, so they come up with the course, the idea of the project. And then I made them to get the project scope right, and they build then they come up with the intermediate project report, and then they give the presentation, and then there's a peer feedback. I'll talk about it a bit more. Some reading, then they get the feedback from me again, and then do the final project. Okay. Now here, let me quickly show you that article before I get into that creation part. So this is from our computer architecture 12 predictive analytics screw-ups. Okay. So begin without the end in mind. Okay. And define the project around a foundation that your data can't support. It's kind of sensitizing them what could be the problems, right? And don't proceed until your data is the best it can be. When reviewing data quality, don't bother to take out the garbage. So basically validation check and all they should be. So use data from the future to predict the future. That is something I emphasize in a lot. Just because in the data set doesn't mean you can use it in the model. They have to see whether the data would be available at the time of prediction. Don't just proceed, but rush the process because you know your data is perfect. So these are things we should not, they should not be doing. Start big with a high profile project that will rock their world. Ignore the subject matter expert when building your model. So here, to actually make them realize the importance of domain, I intentionally give them a project which they would not be familiar with. So there are people from marketing, they're from finance, but I do not give them a data set which has to do with marketing or finance. I'll give them a data set, something like trade flows, something like crime in a particular city. So very, intentionally it's like, so that they do not know much about that area, and then when they see, oh, someone who has dug a bit more in that area have come up with better model, better insights, to make them realize, I kind of give them a very different kind of data set for them to realize that subject matter experts is relevant. Just assume that the keepers of the data will be fully on board and cooperative. We have seen what it takes to get the NDA signed and all. There have been cases where we know everyone is willing to share the data, and suddenly the CU decides, oh, they can't actually do it. So we have to be practical about what we can get. Just don't assume that everything is available. If you build it, they will come. Don't worry about how to serve it up. So sometimes without establishing the value, if you just build a model, then it's very difficult to sell that model. The results look obvious throughout the model. Don't define clearly and precisely within the business context what the models are supposed to be doing. And so this is about the article. So I kind of make them read to reinforce what. All right. So here, this is about it. Now here's the thing. So I give the same data set to everyone. Okay, I give the same data set to everyone, and then I tell them to come up with different ideas on the project. So I tell them, you don't discuss with each other so that your ideas don't get biased. If there's a coincidence in getting the same idea, that's all right. But I give the data set and I ask them to come up with a project. And here I think Ravi was mentioning at some point of time, there's a lot of work involved in terms of coming up with a good prediction problem. It cannot be automated. And once the prediction problem is there, then there are other people who can actually, the statisticians or data scientists can actually crunch it. So in fact, so happens when people the students just enroll in the course, they will say, Prof, should I actually participate in those Kaggle competitions? Okay, and then I tell them, yes, it's important. You can participate in those Kaggle competitions to kind of sharpen your method skill, but then somebody has already defined that problem. But your job would be would involve kind of identifying a business objective which can be achieved by designing a prediction problem. So the Kaggle has already done for you, so it's only part of the story. So you have to be able to design the prediction problem giving the business objective in mind. And the project is actually focused a lot on that aspect. And now how do we make sure that people are indeed thinking in that direction? That's where the framework comes in. So I was talking about ideation, right? What I do as part of ideation is that I make them answer a lot of questions. When they think through answering those questions, they eventually come up with an idea which is a valid one. And I'll tell you what it is. So first, so this is the ideation part, and I put a lot of emphasis on that as far as the project is concerned. So first is identifying the business goal. And if you look at these questions carefully, you will see that I'm actually sensitizing them to think from those angles, from the business angle, not just a pure prediction problem. So the questions that they will have to answer is, who is the stakeholder or the client with regard to the business objective you're proposing? Identify the stakeholder. Okay? And then as description of the business objective, what are the benefits of implementing this idea? What opportunity is it creating? What shortcoming does it address? So identifying value, right? What sort of decisions are involved in achieving this goal? Well, this is the business objective. You identified the stakeholder, identified what value it can create. Now to create that value, what kind of decisions they have to make? Right? And if they make the right decisions, then how do you quantify the success? So there has to be a way that, you know, if you do this, this is how much it will make a difference to your bottom line, right? So they think through these questions, and then once they have done that, next part is, okay, now tell me what prediction problem you will design that are aligned with the business objective. Okay? So they will ask themselves, provide a description of the analytics objective or data mining problem. This is where the prediction is involved, identifying a y or identifying the different x's, such that if you predict y, it helps your decisions that you identified earlier to achieve that business objective. And they then the next question is, this a supervised or unsupervised task? If you're coming up with a predictive analytics project, then it is indeed a supervised task. Is it predictive or descriptive? Well, if they also care about explaining, then it's predictive and descriptive both. If they do not care about explaining, it's just predictive, right? Is it retrospective or forward looking? What is the main outcome variable of interest? What predictors are needed? So at this stage, they're doing the prediction problem. Next is about data preparations. There they see what all data they have, or what kind of data they need to collect, and what kind of data preparations they have to do so that they can go ahead and implement that prediction model. And then once they have done that, the implementation or once they've done that, it's like, okay, then what methods do you choose? Now, based on whether they have said predictive or descriptive or both, they will decide what methods are appropriate for that. And based on the business objectives, they will at this stage identify what are the metrics that they will have to use to find how good the model it is. Implementation and recommendations. So at this stage, so this is to make them think that, you know, it's the problem. The model building is not a one-time thing. It has to be retrained. Okay, sometimes just retraining the model is not good enough. They probably will have to go through again the model building exercise. So I want them to think through that that it's not one-time thing. They have to come up with the criteria when the client should retrain, or they have to specify the criteria when the whole model building exercise has to be redone. So as you see, that these questions will help them think through in a way which converts a business object to a data mining problem, and also evaluation and implementation of that. So that's the framework I was referring to. Once this is done, they present the project, the ideation is done, if there is any issues taken care of, they write the report, they do the presentations, and then the peer feedback. Okay, what is going on here is that sometimes what happens that when we are evaluating others, we are much more critical, much better at finding out this is good, this is bad, this they have missed. But when we do it, we do not do it ourselves as much. So what I do is when the project presentation is going on, I make the rest of them assess the project, okay, and I make them answer questions in a survey form. And so this is what they actually answer while evaluating a project. So is the title of the project informative? Is the business problem relevant and well defined? Okay. Is the data mining problem well defined and does it address the business objective appropriately? Has the data preparation been done correctly? Are the choices of methods appropriate and practical for the data mining problem? How creative the team has been in dealing with the data preparation and applying the methods they have learned? How well the practicality of the solution, as for example, availability of predictors at the time of prediction has been dealt with? How robustly the model has been evaluated, is the evaluation metric aligned with the business objective? How well the issue of overfitting has been addressed? Are the recommendation insightful or significant? Is the guideline for deployment practical and the solution implementable? How did the team manage the allocation of time? That's the last two part of most of the presentation. But when you make them go through taking the survey 10 times for 10 different projects, it's kind of get reinforced in the head what is important to look for in a project. So in a way they'll be not only be able to evaluate the project, when they go back and write their final report, they're kind of sensitized about what they should not be missing. Okay. So this is about the two frameworks that I want to talk about, how you actually give them a questionnaire so that once they answer, they're able to come up with an idea for a project. Okay, that's the framework that I give. And second is the framework where they learn what is important and not important through evaluating 10 other teams. So that's about it. That's another, I think I'm running out of time. I'll not talk about this article. So I put this framework and all in that. I have the other course where I have a similar questionnaire, similar framework that I was not going to present, but I have included that in the presentation. So that's about, okay. Quickly, Roy, do we have a couple of minutes or how?
Maybe one or two questions.
One or two questions? Okay, so any question? I think if there is no question, then yeah. So for the analytics program, they do it using R and W. And when it comes to MBA, I do not do R with them. I do Excel, Miner, and W. Yeah. And any other questions? And probably, given that this slide is there, I also, these are very software, as I brought up the tool, these courses are very software dependent, right? So it takes time. So what I do is, I actually create videos of, let's say you want to do this, what all you have to click where to get it. I actually create videos using Camtasia. That was, I was going to talk about. So that they always have a reference, they can use those videos as reference, so that I don't spend too much time in the classroom and they also do not figure out where the tutorial is and all. So I kind of create videos to learn software. I do use a textbook. One of the authors is Professor Galit Smueli, and I think Nitin Patel, and that's the book. Thank you.